fingernails are 2 on the Mohs scale of hardness. Copper is 3. Pure copper wire is 3 on the Mohs scale of hardness. Calcite is 4.5, I think, a little harder than 4, but not much, and it scratches real easily. And fluorite. Fluorite also has some carbon in it. And when the asteroid strikes, it does so once. It doesn't like happen again and again to keep doing it. It just happens once, and it compresses all that rock immediately underneath, right? So it goes boom, and underneath there's what we call a cone of compression, because the asteroid makes a circular footprint or kind of an oval-shaped footprint as a general thing, like eggs, fatter on one side and thinner on the other, because the planet is turning. So they tend to be moving east to west, planets do. Or west to east, I'm sorry. And when asteroids hit, they come in and bip into the surface, and it makes one little area, this cone of compression, all squeezed together, and people look for it. It's called kimberlite pipes. And there tends to be greenstone, which is olivine, in the original mix, and it turns kind of bluish colored. Okay, so people go spend a lot of time looking for diamonds, where there aren't very many, right? Those cones of compression and asteroid strikes are pretty rare. They're not the only way that diamonds form, however. In fault lines, and fault lines are not just a few kilometers deep, like a cone of compression under an asteroid. They get maybe 3-5 kilometers deep, maybe, if it was a really big asteroid. Fault lines, on the other hand, are open at the other end, 55 kilometers down, where the molten mantle seeps up cracks in the earth. And that's what fault lines are. They're cracks in the earth. And they're at least 45 kilometers deeper than the deepest kimberlite pipe. And they're not restricted to minerals in place. The molten rock itself carries the carbon. And as the molten rock comes up and starts to cool, the carbon and the silicon carbide precipitate out until it's all gone. And they're tied together with double covalent bonds. And the next thing out is aluminum oxide. And there's, I mean, lots and lots and lots of it. Lots of it. That's what this is. And it's mixed with AUPT. And the mountains behind me are just full of it, of aluminum oxide. And it's a deep, dark ruby red. And they're not clear. They're not clear, but they're rubies. They're definitely rubies. Not all rubies are clear, I guess. I don't know. I have a whole bunch of them. And I'm still looking at them to determine what I've got here in Australia, because this stuff is silicon carbide. It's light. It doesn't weigh hardly anything. It's either silicon and carbon or just carbon. Aluminum oxide, on the other hand, is heady and cold. It doesn't feel warm to the touch. Now, it'll warm up. Any little rock is going to warm up sooner or later. Okay, I mean, it's sitting inside. So it's, at least the ambient temperature of the air around it, which is about 75 degrees Fahrenheit in my house, 22 degrees Celsius. And it's ubiquitous. It's everywhere. I started finding it in mountains over in New Mexico. And then I looked at the mountains around me. Instead of looking far, far away, I started looking at the mountains right next to me. And they are absolutely peachy. They are beautiful aluminum oxide. I mean, really beautiful aluminum oxide. And it's massive. I'm going to use it for my construction of turbines. And I'm working on getting some diamond wire saws that I can use on the larger pieces, maybe out in the world. we'll have to figure it out, because there's a whole bunch of it. And where it where it has AUPT in it, it's so full of it that it looks like it's solid metal when you're looking at it from a distance. And this is what you're looking at right there, is solid metal. And if I polish it, you see that it's a checkerboard pattern of light and gold colored stuff. And it is AU and PT platinum. Platinum is a white metal. Let's see if I can hold my hand still here. And it is white, really white. and when it's mixed with gold like this, and it has double covalent bonds, it's as hard as diamonds too. It's a metal, right? I can cut this and use it structurally like a metal, like any metal. I can plane it and make it flat and drill holes through it and bolt it together and make it to look like machine parts. I don't have to hit it or pound on it to make it smoosh together. It's as smooshed together as it can possibly be. And if I run a diamond saw through there, whether it's a diamond wire like I want to use, or whether it's an old-fashioned diamond saw, it's hard. It is so hard. And I have some of this stuff is actually harder than diamonds. It is an 11 on the Mohs scale of hardness, because there isn't anything that scratches diamonds, man. There isn't anything. But this stuff does. It's a first. Another first. From the Mountain Smith workshop and laboratory. Starflyer Industries.